In this video, we are going to discuss about the adsorption process used in the desulfurization or the adsorption process used in the sweetening processes. So the first one is the RN sponge process, and the second is the molecular sieves process. These two processes we will discuss in the category of the solid bed sweetening processes. So now let us look about the first one, that is the RN sponge process. So this is the RN sponge process where the reactions are given here. The sour gases is passed through a bed of wood chips that has been impregnated with a special hydrated form of ferric oxide that has a high affinity towards the H2S process. So simply it is we need a solid bed basically where the wood chips are there and that is impregnated with the special hydrated of the ferric oxide. The reactions that is taking place in this one is Fe2O3 with the H2S that gives the basically the product, and that can again this product is again regenerated using this oxygen equation. The temperature must be kept at less than 120 degrees Fahrenheit, and if we want to regenerate this solid impregnated ferric oxide, then this iron oxide is regenerated by the passing of the oxygen or the air over the bed. So this is a reaction for the regeneration of the ferric oxide in the sponge process. The advantage of this process, it is very simple. It's a simplicity and absolute selectivity for the H2S, which implies less gas shrinkage because CO2 is retained in the gas. It is a relatively inexpensive, very simple process. Disadvantage is difficult and it's obviously it's not a difficult. Yes, as far as the regeneration is concerned, regeneration is difficult and expensive. Otherwise, the work process is not expensive or simple one. But the regeneration required certain difficulties and expensive as compared to the other processes. The second disadvantage, excessive pressure loss through the bed because of the solid bed process, and inability to remove the large amount of sulfur, that is the third disadvantage, and the sulfur disposal problems, that is the fourth disadvantages for the iron sponge process. Now let's about the process flow diagram. It's a simple process flow diagram where the feed, that is a sour gas that is going inside the tower. Obviously we need a two tower. One tower is in a regeneration system, the second tower that will be in the process for the removal of the gases from the natural gas. This is a solid bed, and you can see that the whole reaction is very simple one. This is simply the adsorption process. In this sweet gases are taken out. So this is the cycle of the, if you see that this is a simple cycle of the this one, this way. This is simple cycle of gas. This is sour gases, and after removal of sweet acid gases, it becomes the sweet gases. The remaining step is recycling and all these things. For example, suppose this is a regeneration step, so we need a steam here to provide. We need air also, so air is basically given supplied here. So, and after the air, there are compressors that is being supplied for both the tower. For example, this tower is working as a regeneration system, so that's why the air is going inside. So continuously air is going inside, so that the regeneration is taking place. So one bed is under the regeneration step, and one bed is under the absorption step. So in this way, the natural gas is being the H2S is being separated out, and regeneration is carried out for the other bed. This is the second one, that is the molecular sieves. This is also the one example of the adsorption process. So basically, it is a synthetically manufactured form of crystalline sodium calcium aluminosilicates. So the molecular sieves are the porous in structure and have a very large surface area. That is one of the very good feature for the molecular sieves. The pores formed by the removal of the water of crystallization are uniform throughout the material. That is one of the very good advantage. That is the pores that is at a very molecular level. That's why it is called as the molecular sieves, and that is almost uniform throughout the material. Several grades of molecular sieves are available, with each grade corresponding to a very narrow range of the pore sizes. So that is one of the beauty of the molecular sieves. That's why people are preferring the molecular sieves over the other processes. Molecular sieves remove the component through a combination of sieving effect and the physical adsorption process. They are highly selective in the removal of H2S and the other sulfur compounds from the natural gas, and offer a continuous high absorption efficiency. Because it is working at a molecular level, so we can remove the H2S. Selectivity is very high. We can select the H2S recovery only from the molecular sieves. Also, they remove water also, so you can say the polar compound, and thus offer a dual basically benefit, or you can say the simultaneous dehydration and dehydration both are possible in the molecular sieve process. So that is also one of the advantage, one of the simple process. If I say about the process flow diagram, this simple flow diagram, if you see that this is the feed, that is the inlets or gases that is entering into the molecular sieve bed. This is the bed where the sweetening process is carried out, and then you can remove the outlet sweet gases. So this is basically, if you see, this is only the cycle of the natural gas. Apart from this, all the other things are basically for the regeneration and other processes. So if you see the regeneration system, so the bed is regenerated by passing a portion of the sweetened gas, then preheated to about 400 to 600 degree Fahrenheit, and for 1.5 hours to heat the bed. So that is the process of the regeneration. As the temperature of the bed increases, it releases the absorbed H2S into the regeneration gas stream. The solar effluent generation gas is flared out. So in this way we can regenerate the molecular sieve. So you can see in the diagram, for example, a portion of the sweet gases is now sent back for the regeneration. This is going this way, and then going this way for the heating. So here the heating is taking place, and at such a high temperature, what happens, the bed will be basically releasing the H2S, and this H2S is taken out this way, and then you can just flare it off. You can also take it out from this way, and you can flare that H2S into the atmosphere. So this is the basically process for the flaring and for the regeneration. This is the cooling. It will take some time for the cooling. So that's why we have three different beds. One is sweetening is going on, and one place heating is going on, and one place cooling is going on. So this is all about the molecular sieve process. Thank you very much.